All right, so in this lesson, we're going to look at our next organic family of ethers. And I'm just going to quickly scroll up to what we looked at with alcohols. Just recall that when you have two alcohols and you release a water molecule, you make this organic family called an ether, and you also make the water. So an ether, here we go. All right, an ether has this functional group. It doesn't have a name, but it's characterized by an oxygen atom in between two hydrocarbon chains. Okay. Now, this is going to be another lesson where I'm not writing in real time. So that means that you need to hit pause and copy what you see and then listen to what I have to say about it. All right. So ethers, they're fairly straightforward to name because they're characteristically a hydrocarbon chain with an oxygen and then another hydrocarbon chain. So all you do to name them is use the word. Come on, I want to highlight and it's not letting me. I don't know. Maybe? No? Okay. Well, it's blue. You use the word oxy in between the two hydrocarbons. Now, one of the rules, though, for naming is that if you have hydrocarbon chains on each side of this oxygen, the shorter chain gets named first. So, for example, I have 3 examples right here. All of them are a hydrocarbon chain with an oxygen followed by another hydrocarbon chain. I don't know who you are. Okay, so now that we've named a couple of our ethers, let's look at what happens to the properties because we have this oxygen in the middle of essentially non-polar carbons. So if we look, the adding our oxygen is going to make the ether slightly more polar than an alkane, because now you're going to have a little bit of some polar bonds here and some polar bonds here. But it's significantly less polar than an alcohol. And that's because the oxygen is surrounded by nonpolar hydrocarbon chains. The functional group lacks a hydrogen. And so what that means is that an ether is not able to hydrogen bond. The oxygen, you would think it could hydrogen bond with a hydrogen in the hydrocarbon chain, but that's not the case. So the oxygen results in it being a little bit polar, but not a lot polar because the oxygen is surrounded by the rest of the molecule is nonpolar. So if we're going to look at some physical properties of our ethers, and I'll just scroll up so we can see them all here. The melting boiling points are going to be significantly higher than alkanes, but they're lower than alcohols. Again, it's because this idea that the ether is slightly polar, and the oxygen allows for some dipole-dipole attraction, which, remember, that's the third type of intermolecular force that occurs between some polar molecules. Hydrogen bonding, it is not going to hydrogen bond, but it will form dipole-dipole attraction, resulting in intermolecular forces that are stronger than the London dispersion force of just a straight alkane, but not as strong as a hydrogen bond. Because the ether has a whole bunch of nonpolar hydrocarbon chains and a polar bond with the oxygen, ethers are actually soluble in polar and nonpolar solvents. So they're actually used to dissolve things that water cannot dissolve. Okay. And then we'll just quickly look at chemical properties. Ethers are really combustible. They react with oxygen, and they react with halogens. They are, and then they actually have a wide variety of uses in society. So in the past, they were used as an anesthetic, which means they were used to like put people under for surgeries. But ether is actually a fairly dangerous anesthetic. If you give the patient too much, then you can kill them. And the vapors of the ether are very dangerous for the other people in the operating room. So it's also like really highly addictive. And so doctors and nurses who used to administer ether would become addicted to the ether. Because because it has some polar and nonpolar features, it's used in labs as a solvent because we can dissolve things in ether that we cannot dissolve in water. And it's also used in aerosol cans as a propellant. So something like hairspray, spray paint, etc. Okay, so that ends our lesson on ethers. We're going to have some practice for you to do. Just remember the big thing for these ethers is that they have properties in between an alkane and an alcohol because they can make intermolecular forces. And remember with the naming that the shorter chain goes first in the name, followed by an oxy, and then the name of this longer hydrocarbon chain with the ending. Okay, that's it.